Then one more measures of dispersion. So that is coefficient of variation. So when we will use this coefficient of variation, when we have to compare two or more distributions. So when we are making the comparison between the distributions. So if one distribution, we can calculate that mean and standard deviation of that particular distribution. According to that distribution, we can make that assumption, we can make that decision for that particular problem. So when we have the set of distributions are there and we have to compare those to those set of distributions, means here we have A, B, C, D of n distributions we have. While when comparing these distributions, so it is just we are very difficult to compare the distribution with the help of individual means and standard deviations. So for that purpose, we are calculating this coefficient of variation. That is, this coefficient of variation is to compare two or more distributions. To compare two or more distributions we have. So here it is also called as relative measure of distribution dispersion. Is nothing but coefficient of variation. So here what is the formula for this coefficient of variation is coefficient of variation is equals to sigma by mu. Sigma is standard deviation of that particular distribution. Mu is what is that mean of that particular distribution into 100%. So standard deviation and mean. Standard deviation by mean into 100%, then we will get the coefficient of variation. Then from that coefficient of variations of this individual distributions, we can make that a decision for that particular problem. Here we are taking one example. Here in that particular business concern, we have two types of two typists are there. That is typist A and typist B. The performance of this typist A, that is, he can type 30 pages average per day. The mean value of this typist A, mean pages means he can type and average 30 pages per day. And with the standard deviation of his standard deviation is 6. That is variation from the mean is 6. And similarly, here we have the one more typist, B typist is he can perform means he can type 45 pages on an average per day with a standard deviation of 10. So here this is individual distributions we have, that is typist A and typist B. So we have to means we have to compare these two A and B. So performance which performance is best. So for that purpose, here we have to calculate that coefficient of variation. So coefficient of variation of A is equal to sigma by mu. What is the sigma here? Sigma is equals to 6. This is equals to sigma 2. That is standard deviation of B. And also mu is equals to 30. That is mu for mu 1, 45 is mu 2. So here first we are compare means we are calculating this coefficient of variation of A type is, that is sigma, that is 6 by what is that 30. 6 by 30 into 100%, that is total 20%. 6 by 30 into 100, then we will get 20%. Okay, next coefficient of variation of B, that is sigma by mu. Sigma how much it is? 10. Then mu 45. So 10 by 45 into 100%, that is 22.2%. So this is coefficient of variation of A is 20%, coefficient of variation of B is 22%. Means here this indicates 20% and 22% indicates A is performing. So here of course A is performing less than B because A is on an average is typing 30 pages per day and B is typing 45 pages per day. But comparing to the variation of his performance, the A is very much consistent than B. Why? Because his variation of this B is 22.2% and variation of A is 20%. So here in the one while taking the decision according to the performance of these two typists, so A is more consistent than B. Of course, B is typing more pages, but he is inconsistent. Means the variation is much more than that A. So A is more consistent than B. Means when we are comparing these type of situations in business concerns, we can use this coefficient of variation. The next concept is skewness. Skew means it's diverting its route. That is nothing but skewness. So here when the distribution got skewed, means it is bending one side. So that is nothing but skewness. So here, when we can say the distribution as the skew distribution, that is mean doesn't equal to median, that is equal to mode. So mean is not equals to median, that is not equals to mode. These mean, median, mode are means taking three different values, then that particular distribution is called the skew distribution. So when the distribution is in normal curve, so the general distribution is nothing but unskewed distribution, that is equals to, here we can show is the graphical representation. This is the values it can takes the distribution. So here, when the mean and mean value will be here, median value will be here, and mode will be here, means the total value mean is equals to median is equals to mode, it can take the normal distribution values. So that distribution is called unskewed distribution. So symmetrical means we can see it as a symmetrical distribution. So coming to the skewed distributions, these two are skewed distributions. Here, this is positively skewed and this one is negatively skewed. Okay. So here, so coming to this positive skewed distribution, so while coming to this positively skewed, we can consider this the skewness, the normal distribution curve will be here, and it is taking this highest point of the mode, and it is going down, and it is means going like this. So this is positively skewed distribution. So here in the positively skewed distribution, this top point is nothing but the mode, and in this medial is nothing but the median, and this may be the mean value. So here mean doesn't equals to median and that is equals to mode. Here mean is what is that? Less than median, median and less, sorry, mean is greater than median and greater than mode value. That is positively skewed distribution. And coming to this negatively skewed distribution, here it is starting from here and the distribution will be like this, and it will take the upper limit of the distribution and it is go down. So this upper limit is called the mode value, and in between this is called the median, and this is the mean. Here the mean will be less than median and less than mode. Okay, but in these two cases, both are all are not equal. Mean does not equals to median, does not equals to mode. So this skewness we have to find out how much skewed it is positively, how much skewed it is negatively. So to find out this skewness, we have different methods to find out the skewness, that is Kelly's method of skewness and Bowley's method of skewness, and kurtosis we can find out with this help of this skewness. So to measure the skewness, that is either it may be positively skewed or negative skewed or symmetrical distribution. So if we have to measure the skewness, here we have the four methods to measure the skewness. The first one is Carl Pearson measure of skewness. Second one is Bowley's measure of skewness, and Kelly's measure of skewness, and Moment's measure. So all these methods we are using, and we are going to measure the skewness one by one. We will discuss the first method, that is Carl Pearson.